Alright guys, let's go through the setup for the liquid level lab with the lab volt stations. So the first thing you need to do is you need to go, once you've opened up the LV Pro Sim, you go to Process, then you scroll down to Work with the Control Trainer. Once you've done that, then you go over to Setup, and then scroll down here to Enable the Communications. And once you click on that, then the computer should be then talking to your trainer. The way to see that is on the back of your I/O interface here. On the back, the LEDs should be chirping at you. Okay, then you know that the computer is talking to the I/O interface. Okay, the other wiring that we need to do is we need to bring two wires. You can see here that I've got this wire here going from the analog output, and I've got the common going to the common. And if we follow those guys over, they're going over to the drive for the pump. And here's our 0 to 5 input, and there's our common. So that's going to send the 0 to 5 signal from the computer over to the pump. So we'll turn this bad boy on. Now, we don't have the computer sending a signal to the pump yet, but once we start sending a signal to the pump, then it'll get up and running, and you'll see that the liquid level starts to increase in the tank. Now, piping wise, we've got the output from HV2, and you can see here on this diagram here that the water comes from the pump over here. HV2 is closed, and the water comes out of this hose, and all we have is this hose going over to one of the ball valves. So that's going to control our fill. That now comes over with a short lead over to the bottom of the tank here. And then we'll have the drain, so the drain will come over here to this ball valve, and then from here you can see that this goes back to the tank to HV1. HV1 is open, and that's just going to allow the water to go back into the tank. The last thing to check is HV3, and you can see that HV3 is in the upright position, so the water is going to come from the tank, based on this diagram here, from the tank and back to the pump. Beauty. The next thing we need to do is make sure we don't get wet. So there is a tube that goes from the base of the tank all the way up to the top here. So if you don't cap this guy off, you're going to get wet. So close that guy off, otherwise the water is going to come up the tube and spray in the face. And for this liquid level, we're going to be looking at an open tank. So you can keep this open, but guaranteed your partner is not going to be watching, and then the water level is going to increase. So why don't we just put another tube here that goes back to the tank, okay, into this port right here, and this guy just goes right into the tank. So that port goes right into this tube right here, and if we have an overflow, the water will come from the top of the tank and then go back in. Now this also vents the top of the tank to atmosphere. So we have 14.7 pounds gauge applied to the top of whatever water column is in the tank. Excellent. Okay, now for the additional wiring, we're going to be using this differential pressure or DP cell. And what we've done is we've taken this tube at the base of the tank, which is going to look at the head pressure that develops here. And that pressure is going over here to the high pressure port of the DP cell. Okay. If you want to get wet, then connect it into the bottom part here. This is a check valve, and if you connect it up here, water is going to come out of this end here. So again, from the base of the tank over to the high pressure port of the DP cell. Now whatever the top of the tank registers, in this case we have atmospheric pressure, then the low pressure port of the DP cell also registers the same thing. So we just have this open to atmospheric pressure. We need to provide this guy with 24 volts, and we're getting that 24 volts off of this unit right here. Okay, on your diagram you have a wire going from the 0 to 5 output back into the I/O interface. We're going to negate that for today, and all we're going to do is just look at the voltage that develops between the 0 to 5 volt output and the common. It's a DC voltage, so we have our voltmeter set for DC volts, and On voltage, you're not going to blow a fuse, but just do me a favor, it's best practice to have the unit off before you start changing the settings on the meter. Once the meter's set and ready to go, then energize your circuit. Excellent. Okay, so next thing we need to do is we need to start filling up the tank. So we're now going to go over to the computer. We're going to click on this guy and we can grab it and drag it over. You can hear that the pump is now increased. Now you can use the arrow keys to slowly increase and decrease the output. Okay. Don't have the pump going too fast, but now what we're going to do is we're going to close either one of the valves, and you can see that one is used for the drain, which is not working yet, and one is used for the fill. So we're now filling up to a level where we get enough back pressure on the lines to actually drain out. So again, we'll use the ball valves to control the level in the tank rather than using the output on the computer. The output on the computer is staying the same. And now what we need to do is we'll drain this guy out. And now that we have enough head pressure, now you can see that it's starting to drain out. You may need to just move the piping around a little bit just because you may have an air bubble stuck in somewhere. Okay, and now essentially it's draining out. Okay, we're going to now stop it at this level. Okay, what I'm going to do is I've got to take a longer tube, because in this small tube that goes from the base of the tank over to the high pressure port, there's most likely a small air bubble that's in there. So what we're going to do is take a longer tube, go from the bottom check valve here over to the tank and bleed out that unit now. So just let me do that for 2 seconds and we'll bleed out the air bubble. Sorry guys, 2 seconds. Otherwise what's going to happen is the level of the tank is going to increase, and all it's going to do is going to compress and decompress that air bubble. So now we're just dropping that tube into the tank. Once we see a steady flow, then we know that we no longer have any air bubbles in that small line, and then we can disconnect it from this bottom connection. Some of you will keep it connected and then your readings will be all messed. So again, you need to now take this guy out of there. Now that we've let off that air bubble. And the only small tube that you should have would be from the base of the tank to the high pressure. Okay, so that's a little bit misleading in the lab, but again, the only tube that we have is going from here to this high pressure port. Now, you want to make sure that you don't move this guy around. As soon as you move this around, it's going to change the relative level in the tank. So don't touch this tube once you've calibrated. Excellent. Okay, now what we're going to do is we're going to drop it down to 10 centimeters. Okay, so we're looking for this guy right here. Now it takes a while to drop down because you barely 1 psi of back pressure when you get the column all the way to the top. So it takes a little bit of time to get to the 10 centimeters. Once it does, we're going to change the 0 potentiometer. Okay, so we're 10 centimeters now. What we're going to do is, the voltage I'm reading now is like 1.3. So it's gone out of calibration. I'm going to increase the 0 and the span all the way up. The voltage is now 5.65 volts. And I want to reduce that down by adjusting the 0 potentiometer. As I adjust the 0 potentiometer, that voltage is going to decrease. I want the lowest level in the tank, 10 centimeters, to correspond with the lowest voltage value. Okay, now you'll notice that I can keep cranking down the potentiometer, but the voltmeter doesn't change. So what I'm going to do is just bump it up just until you see it jump like that, and we'll drop it down again. So that must be the lowest voltage we can get out of this transmitter. Okay? Now what we're going to do is we're going to increase the level in the tank. And we're going to go up to 50 centimeters. 50 centimeters is the highest level that we're looking for. A little little bit more. Beauty. Okay, so now we got 50 centimeters. That's the highest level. Well, we need the highest voltage output as well. Well, that sucks because we don't have any voltage in. So we need to decrease the span. And by decreasing the range, or the span here, then you'll notice that the voltmeter starts to slowly increase. So we need 50 centimeters to correspond to 5 volts. So it will slowly increase and then it will jump up. There we go. And we're going to get this to settle out. Come on, buddy. At about 5 volts. Beauty. Now, as soon as we change the span, we've now screwed up the zero. So it's a little bit like watching paint dry, but we now have to drop the level down to the 10 centimeters, readjust the zero, go up to the 50, readjust the span. Between the 50 and the 10, we have 40 equal values. So if we're starting at 10, halfway is going to be at 30 centimeters. At 30 centimeters, we're looking for 2.5 volts. Well, right now we're at 30 centimeters, halfway, and we are not reading 2.5 volts. So we're not calibrated yet. So we're going to keep dropping this down. Every time you adjust the zero, you have to readjust the span. Every time you readjust the span, you have to readjust the zero. You're trying to find an equilibrium where the two kind of settle out and give you a calibrated value. Okay, this guy's slowly coming down to 10 centimeters. Beauty, we're at 10 centimeters again. And the voltage is now a little bit higher because we adjusted the span. And we're now going to adjust the zero to give us a lower voltage. Okay. Again, we'll just bump it up and then back it off a bit. Beauty. Okay, and now we'll increase the level in the tank. We'll check it here at 30 centimeters again and see what value we get. Okay, not even close. We're at 1.7. Okay, 50 centimeters, and we're now adjusting the span to give us 5 volts. There we go. Okay, let's drop her down. We'll go to 30 again. As we're dropping down the level of the tank, then obviously the voltage is dropping as well. There we go. Pretty good. Let's see, I'll just increase it a touch to get to the 30. I mean, that's as close as we're going to get in the lab now, 2.495. Beauty. So we are now at half the level of the tank, and we've now calibrated it now to give us half of that 0 to 5 volt range. Beauty. Now we should be able to get a linear output now. So if we drop it down to the 10 centimeters again, and then take our individual voltage readings, then we should find that we get a linear increase in voltage as that head pressure develops at the base of the tank. Now that worked out with just calibrating it twice. You may need to do it 2 or 3 times just to get her to settle out. Okay, so right now we'll leave this value, so 0.116 for our lowest value. That's at 10 centimeters. Okay, we'll increase to 20 centimeters now. Okay, and we're looking for 1.25. We've got 1.262, fairly close for the lab. Okay, so that's 20 centimeters. We'll go up to the halfway mark, so another 10 centimeters. for linear, we should go up to 2.5. Whew, that's gorgeous, 2.501. Excellent. Okay, let's check the 75% now. So up another 10 centimeters. Okay, we're at 40 centimeters and we're supposed to be at 3.75, 3.76. Excellent. Okay, and our final one will go up to the highest value again. I keep hitting the wrong valve. Up to 50 centimeters. Okay, and at 50 centimeters we're getting 5.05. Right on. So now we've got a linear increase in the amount of voltage that's present on the voltmeter based on that level in the tank. Now, it's an open tank, so the top of the tank is open to atmosphere. Now that we've got it calibrated, we might as well screw it up. So the next thing I'm going to do is I'm going to now take this unit off the back plate, and what we'll do is we'll drop it down. Now when we drop it down, all of a sudden the voltage increases. Well, that makes sense. We've increased the level in the tank. Now the level in the tank is all the way down here. So with that increase in head pressure, we'll also have an increase in voltage. If we go back to our calibrated position, then you can see that as soon as you start fooling around with stuff, it will go out of calibration. So now this was 5 volts. I must have bumped a valve. Let's see if it goes back down. Let's drop her down because I can see that it didn't go down to 50. Let's see what we got at. Okay, so we're still pretty good. We're at 4.99. Okay, so again, if we drop this guy down, then the voltage increases. The level in the tank is exactly the same. If I now lift this guy up, so it's higher up, well, now the level in the tank is no longer 50 centimeters. It's now less than that, and you can see that the voltage has dramatically changed. It's reduced because effectively I've reduced the height of that liquid column. Beauty. We'll go back to our calibrated position. Everything looks good. We're still at 5 volts. Now, what we'll do is, let's drop the tank down a touch here. As we drop it down, then we have our normal linear relationship. We'll go down to 30 and see if we're still calibrated. Beauty, there's 30 and we're at 2.507. Excellent. So now what we're going to do is we're going to remove that vent that we had for atmospheric pressure. And we're going to pretend like we have a closed tank. So what we're going to do is we're going to close the top of that tank off there. And what we'll do is we're going to increase the level in the tank. So give me 2 seconds, let me grab a cap here. I forgot to grab it. So what we'll do is we'll cap off the top of the tank, and then what we're going to do is we're going to increase the level in the tank a little bit. Now we're still at 2.5 volts, or fairly close. Now as soon as I close that off, you can see that the value has now changed. If I now open that to atmospheric pressure, it goes back to being calibrated properly. So again, I'm closing off the top of the tank. We have a closed tank now, and I'm going to now increase the level in the tank. So all I've done is just increase the level in the tank just a slight amount. And now the voltage is peaked. It's at 6 volts. And the level in the tank is only increased just barely. We're just above 30 centimeters. So that's because the top of the tank is now pressurized, and all that pressure is going down to the bottom to the pressure cell and increasing that pressure value. Now if I drop the level just slightly, all of a sudden you see that the voltage basically disappears. Well, the reason for that is because now we have a vacuum at the top here. It's negating the pressure, or taking away from the pressure that's developed at the base because of that liquid level, and we're basically reading no voltage. Now as soon as I release that top, then everything will go back to the level. If we go back to 30 centimeters, we'll see if we're still calibrated here. There's 30 centimeters and we're still at 2.5 volts. So if we had something like that where we had a closed tank and we weren't able to deal with that increase or decrease in pressure, well then we'd have to negate that pressure at the top. So usually with a closed tank, you would take another tube from the top of the tank over to the low pressure port of the DP cell. So that whatever the top of the tank registers, the DP cell registers as well. Right on, I think we've covered everything. We've looked at how to accurately set this guy up to give us a 0 to 5 volt signal from 10 to 50 centimeters. At 30 centimeters, we're getting half of the voltage range. And then we talked about the fact that this has to be basically in line with the same pressure port that we're looking at. If we change that level, it skews our values. Even changing this tube here will then adjust your values as well and skew them. So be careful not to bump that tube or else you'll go out of calibration. All right guys, thanks very much. And the next one we'll look at is probably taking the next settings if you're doing the advanced instrumentation, taking the settings on the computer and sending a signal back to the computer. Right now all we're doing is we're just looking with our voltmeter at that 0 to 5 volt output. So we've got to look at how to get that voltage over to the computer and have it register on our display here. So that'll be the next video.